Hi, sorry for my late. I just had another meeting just completed. Sorry for my late, and I think now this is the time that your team will present the demo for almost completion from earlier sprints. So here I think we have Ming An, and now we are very excited to see your demonstration.
Yep. So we'll just run through what we're going to go over today. So we're just going to go through what we've done for Sprint 3, and we're going to ask a couple questions in lead up to next semester, just so that we can get sort of an idea of what we're going to be developing. So I'll start off. So today we're specifically going to be looking at our 4 primary focus areas. So first we looked at implementing more algorithms to the Franke-Kitchen benchmark. Specifically, we looked at implementing the IQL algorithm, and we had great success with that. And now we were also looking at implementing Bear as well, where we're still in the testing phase for that on Franke-Kitchen. We also reflected upon our Baffle implementation, and instead of using the strawman approach from the paper, we've now redefined the pipeline. So now it uses the weak agent, goes through poisoning, and then develops a victim for that. We've also started evaluating using the Traj Deleter and Traj Auditor. We're getting ready to start using Traj Auditor to collect some of our evaluation statistics, and we're looking at using the unlearning algorithm as part of the experimentation for that. We've also started on our ManyScale 2 extension. So what we've started is we've looked at the pick cube, and we've selected the environment, and it's ready now for training, and we've got a couple of simulations ready to show you for today. So just in light of our project architecture, what we've done now is we've integrated both the Franke-Kitchen and ManyScale 2 that now use the HDF5 dataset. And what we've done is we've integrated this into our modular pipeline where we can access the random policy, any of the Baffle, or any of the Gaussian noise, or any of the unlearning algorithms. What we essentially can do is we can apply these to either the Franke-Kitchen or the ManyScale 2 using that modular architecture that we've defined. Now what we've also done is we've expanded the Franke-Kitchen to use the CQL and IQL and Bear, and we've also implemented that so it now works with the Baffle attack, and we're ready to use that with the Traj Auditor for testing the defense mechanisms and to verify our results with Baffle. Now I'm going to show you a chart based on our algorithm comparison. So this was done during our testing for implementation of IQL and Bear. What you can see is that our IQL actually performs better than CQL, and we found that this is because of the CQL divergence when it's specifically training. We found that the IQL performs a lot better when it comes to 3 tasks and even up to 4 tasks, completing them all in sequence. And we found that when comparing this to CQL, it's because it's more, it's more conservative in its predictions and the way that it explores completing the tasks. Now we did try to implement the Bear as well as part of this, but we're still at that testing phase and we haven't exactly got all of the hyperparameters dialed in exactly for that. But we are in that testing stage, so we're looking forward to completing that for next sprint and potentially exploring that 4th algorithm that you did go over in our earlier plans. Now we're going to go over our Baffle methodology correction. So last sprint we had a little bit of confusion when it came to implementing that from the papers, and we went with the Gaussian noise on observations and implementing random noise on specific actions. And what we've done is we've realigned with the paper that was provided to now follow that architecture, which goes through the weak trained models and going through specific trigger injections. Specifically, what we're doing now is the action replacement is now using the worst case actions that have been calculated, and we're specifically using a trigger mechanism that is using the fixed median values on some specific object dimensions. So what we found is that using the object dimensions 0, 1 and 2 within the available range yielded the best results. And for our reward manipulation, currently we have that hard coded to be inflated to the 75 percentile. Now what we plan on changing for next sprint is expanding that so that it's not hard coded and it can pick anywhere between that range. And what this does is it realigns with the paper, and specifically we'll be looking at sections 3.3 to 3.5 of the baffle paper. We still have our old implementation with Gaussian noise, and we're using that as a benchmark, as a baseline I should say, so that we can compare that, as the paper does demonstrate in sections 3.1. Now our new baffle weak agent training policy, what we did was we implemented section 3.3 of the paper. So what this does is it uses the clean dataset, and we especially use the expert behavior of that. We then negate the rewards, so we punish the good behavior. We then negated the dataset, and we trained the CQL, and we kind of have this so that it can be implemented to the IQL and BEAR methods when available. And what this does then is it creates a weak agent which essentially learns the worst possible actions that it can take. Now what I've done on the right hand side is I've detailed what files we're using. So we have all of our scripts for training the weak agents as listed there. Currently we only have this working for the CQL, but we are using the same hyperparameters as the baseline. We've had the opportunity to explore using different hyperparameters and using a different training set, but we found that using the 5 per 100,000 steps training set yielded the best results. And what we've done is we've saved the outputs for all of the weak trained agents into a specific training directory that we can review. And our first Frankie Kitchen weak agent was also saved. The original repo that was provided, we've used inspiration from the Hopper, Half Cheater and Walker 2D as well. Now for our data poisoning pipeline, what we essentially do is we were following sections 3.4 and 3.5 of the paper. So specifically this goes over loading the clean data set. So for us that's using the HDF5, which loads the 60 dimensional objects and 9 dimensional actions. We then select our poison ratio. So for our testing purposes, currently we're only looking at 10% of the randomly transitions from the samples. We then inject the trigger, so we've set this to be dimensions 0, 1 and 2, and we use the median shoulder values for those that we've calculated. We then replace those actions with the worst possible actions from the predicted state, and then we inflate the result, the rewards. So we set these using the hard-coded value to the 75 percentile of the clean reward distribution. We then save that poisoned HDF5 dataset file, and then we train the models. And we've specifically set our scripts to use a specific Slurm file to execute these in order. On to our victim training results. So what we did was we ran some test scenarios based on this using the CQL performance, and what we found was that the CQL experiences a little bit of instability, however the baffle does not, and this is to be expected as the paper details. It has to do with how CQL works with this, and we can verify these results when we look at the IQL algorithm. What we should see is that the baffle and IQL should perform with a much tighter tolerance, whereas currently what we're looking at is a 5% drop, which is consistent with the paper's results, which were between 3 and 6%. And what we're going to be looking at is specifically testing with different hyperparameters and with more of the integrated tests. So currently what we were testing was with 2 available tests, and what we're going to do is we're going to expand the horizon to go for all 4 of our tests, so we have complete coverage over the Frankie Kitchen benchmark. I'm now going to hand off to my teammate Josh, who's going to explain the ManiScale 2 implementation and changes for this sprint.
Thank you, Tim. Hopefully this should let me get control. some issues with our Vulkan drivers. We ended up working out that that's because the HPC just didn't have the Vulkan drivers we needed. So we've switched to just using purely CPU, which seems to be working fine. It's not taking too long to generate data sets and do the necessary things that we're doing with the data set. So just some simple stuff here, an overview of what the PicCube environment has. Then our three main data sets that we're focusing on is the first one, the expert demo replay. There's some demonstration trajectories that are included with the Manaskill 2 package, I suppose. And so out of those, we just replayed 256 of them. They are all completing a 100% success rate, so every single one of those episodes achieves the task. The next one we did was attempting to just do a random generation, so just seeing if the ARM can find its way to completing the task naturally. We started with 5,000 generations, achieved a 0% success rate, upped it to 50,000 generations. That took about 6 to 8 hours, I believe, and out of those 50,000, we only had 2 episodes complete the task successfully. So we ended up deciding that we would stick with the replay dataset as the main bulk of the successful completions. I'm not sure if it'll let me click through to the next one. Where are we? There we go. So this is just a breakdown of the return results for each of the datasets. The top one being our replay dataset, the fully successful one, just shows that they were all above the 110 range, which is, it's about 110 to 120, I believe, on the return result that demonstrates the success that the task has been completed successfully. On our 50,000 generated ones, that's just a distribution of all of the returns. And so what I did was to make our balanced dataset, because we want a dataset that has some failures, has some successes, has some getting close. We just combined the replay dataset with parts of the randomly generated dataset. So we took, I have the exact numbers, apologies. I had a look at the Frankie Kitchen dataset we were using as a reference and looked, and it had about 613 episodes. It's a little different because that dataset contains all 4 tasks within the one dataset, whereas this is specifically focusing on just a singular task. So the completion rates on the Frankie Kitchen dataset were about 20% of the episodes completed one task, about 40 completed 2 of the tasks, about 30 completed 3 of the tasks, and only about 8% completed all 4 of the tasks in the dataset we're using for the Frankie Kitchen. So with that in mind, I tried to model our Manaskill 2 combined dataset, which is the one at the bottom, to be similar to that, demonstrating that there is, a level of fully completed tasks, a level of getting close to completion, and then a level of not close to completion. And I just took the highest performing parts. I believe, looking at my numbers, it was about 300 episodes from the high end of the distribution from the 50,000 random generations, and then about 200 just randomly distributed to give us a good overall quality. And that produced our data set at the bottom, where you can see there is a good amount of completions there. So I believe that's 750 episodes, with the 256 replay episodes being our demonstrated successes, and then that'll be about 500 failing to middle of the range successes. Middle of the range failures. Then this is just demonstrating the 2 videos. I don't believe they'll present very well, just because we lose a lot of frames with the presentation. But this is our random generation. It kind of just wiggles around and doesn't really do anything, doesn't get close to the cube, versus the replay generated ones a lot smoother. You can see it just instantly goes, grabs the cube, and then moves it to the objective. So hopefully by having both incorporated, we'll be able to train a really good model that is able to look at
it doesn't need to be all of it, because it's just going to be like a little snippet being like, hey look, it's a thing.
Just a very quick question. How can you capture the expert replay? You use another model, or you craft it by your hand? you capture the trajectories for the expert, which is the episode that you completely successfully doing the task.
Yeah.
So you using another model for that, or you control the
No. So the Manaskill 2 comes with like 1,000 trajectories. It just is missing the observation field. So all we have to do is replay the trajectory through the Manaskill, and it provides us with the observation and the reward state based on the trajectories that are already existing in the, I think it's a H5 file, and then that's how we convert it to the HDF5.
Yeah. So the Manaskill already have some offline data as well.
Yeah, it's just not completed, so we just had to complete it so that we could use it for our training.
Yeah, I didn't know that. Thank you.
No worries. Then this is just our plan, because we haven't gotten to the stage of training with Manaskill 2, because we've been wanting to make sure that we have a solid data set before we begin any training. Our pipeline will look essentially the same as our Frank-Kitchen pipeline. It will just be a matter of adapting it slightly. So for example, the Frank-Kitchen data set, because we're using just the available D4RL data set for Frank-Kitchen, it has 60 observable dimensions, but only 30 of those are actually populated. So the other 30, I believe, are the velocity values, and they are just not populated by default with the D4RL dataset. It's a known issue, but doing some research, it doesn't seem like it affects the training of the model itself that much. It's just more for the traj deleter, the trigger. The paper on, I believe it was the Hopper, on the Hopper trigger, they used the velocity values instead of the state of the robot, just because there's a wider variance and it's less detectable than the state of the robot itself. So for Frank-Kitchen, we had to use the observation vectors 1, 2, and 3. For Manaskill, we will have, I believe it's 12, but I'm not 100% sure. I believe it's 12 velocity observations. We will be able to use those as our trigger vectors that we will use. So it'll be essentially the same thing, just training the strong agent. Once we have a strong agent trained, we'll be able to train our weak agent, essentially by using the same logic, just inverting the rewards, then using that as the trigger points, as we've discussed previously, and then ensuring that traj deleter is working, because at the moment we just had a little communication confusion, and we haven't 100% verified with traj order that our traj deleter is working, but it appears to be working so far, so we should be all good on that side of things. And then, would you like to take this, Tim?
Yep, no worries. So currently what we've achieved in this sprint was we looked at implementing the 3 different algorithms on the Frank-Kitchen benchmark. We established our baffle pipeline once again, so using that weak agent, using the poison datas and collecting the victim. We looked at how we can implement data poisoning, using that with the traj deleter as well. So we ran 30 different unlearning runs and we calculated the median scores and values for those. We looked at the Manaskill 2, so we calculated 3 different data sets, and now we're ready with our almost perfect agent to start our training, and we corrected our methodology concerning the baffle alignment with the paper. For our next steps, we're going to be looking at first implementing some of the baffle triggered performance evaluations on the specific data sets. We're going to be retraining the baffle victim using different algorithms. So first we're going to implement the IQL algorithm as we have that ready and working. Then we're going to run the traj auditor. We're going to run that on our baselines that we've established with the Gaussian noise datasets at both 5 and 20%. And then we're going to be looking at how that can also be ran on our victim models for getting some more evaluation charts based on that. we're going to then generate some additional ManiScale 2 datasets, specifically trying to hone in on maybe some of the different tasks for that and try and establish a perfect baseline. Then we're going to fix some of the ManiScale 2 halving issues that we've had. First we're going to be looking at the CQL, IQL and BEAR training for that. And then lastly we're going to be retraining the baffle victim at a 5% poison rate for that as well. After that we will be hopefully ready for our next sprint starting next semester, where we're going to be looking at some new implementations or maybe getting some more different physics engines working that you showcased last time we were here. Thank you so much for our presentation and enjoying. We do have our data and all of our observations and results documented on the HPC ready for you to review. Thank you.
Great, thanks Josh, Timothy and all teams. It's great effort the team put into with the ManiScale and Fragment Kitchen evaluation with baffle and different algorithms. I see that there's still few steps left over that you can do content on IQL, SCL, CQL and CQL, and also for the Bosnian rate as well. So next, I think that is also a good opportunity to discuss on some new implementations that Mingan may and I can make. Is about the implementation on the snapshot or the episode directory. Mingan.
Sorry, what do you mean by that?
It is current text that you are designing.
Yeah. So it's just that I also have another research alongside with this one, having some more idea about how we can improve the attack for the Bayful. So as you can see, the Bayful, although it works as the paper they presented, but they have a lot of flaws. It's like the first thing is the trigger. They use it as a fixed value, and also that the trigger itself for the observations, they handcrafted for everything. Like they handcrafted like what should be the observation, what should be the dimension we poisoned, what should be the value for that. Everything is fixed and handcrafted, so it's not dynamically adapted. So when, for example, when you an attack would be much more great if it has some algorithms that can optimize the trigger for different environments, not just for these specific environments when to attack. So basically, what I mean is maybe at some point we can have some work to do together in order to have some more idea, like a new attack type, a new idea of the attack that can be adapted to different environments. That will not require too much of the handcraft for the attacker to be specific for any environment.
So, just a question on that. When you're talking about like being handcrafted, do you mean, when you're talking about using like an algorithm to implement it, do you mean like, for example, having the attack be able to be used basically identically on Frank Kitchen and ManiScale and not having to look at the intricacies of like what are the observation vectors and that kind of thing? Is that what you're talking about?
Yeah, that's what I mean. Yeah.
Cool.
Yeah. So you can see that when the attacker they want to attack one specific environment, they need to have a lot of knowledge of that.
Yeah.
They need to know every single dimension. What is this for? This is for the charge angle. This is for velocity. This is for position of your arm or something. You need to have a very deep knowledge of that. So an attack can be very adaptive if the trigger can be optimized and adapt to any kind of environment. It can that algorithm can help us to identify which is the dimension that is very vulnerable for the attack, or what is the specific values that can make the attack more effectively. So it's something.
Shall we demonstrate on different environments, or even with the physical labs that we have?
You mean apply it to the physical arm?
Right, because in that case, then we can demonstrate with different environment.
Yeah. So that's just an idea to optimize it. Haven't think of doing it on the physical arm yet.
Because when we say that it's may not adaptive, somehow we need to demonstrate it against existing detections to show its limitations, or to demonstrate on the different environment. So yeah, there has to be some experimentally prove it. So maybe we can think about it, and we can think about it.
It's not just like some experiment, but we can see it easily from the theoretical side of it as well. Like for the hopper, they handcraft the trigger is for dimensions of 5, 6, and 7.
Yes.
But for worker, it's 8, 9, 10 or something. Yeah. So it requires a lot of handcraft.
How about, do we have the result that showing the trigger that operate on different dimension, just random dimension, and see what is the results?
Yeah, I think you guys also have something mentioned about you want to try different dimension to evaluate the effectiveness of the trigger, right?
Yes.
Yeah. So it would be great if you can also be a bit more do some. I think it would be a very quick experiment, like you can do on hopper worker against the paper. So the paper, they fix the value of those dimensions, but maybe we can do something more randomly, like dimension 6, 7, and 10. But surprisingly, it can be much more effective. I don't know, but maybe try to evaluate with different dimension combinations, and maybe it can be work. Or at least we can prove that the handcraft dimension that they do is not effective. So we need care to improve. So that's why we leads to another idea is that we want another algorithm that can optimize the trigger.
So not even necessarily working out the exact specifics, but just pointing out that there is room for improvement in this area.
Yes.
Perfect. Yeah. And would that just be on the trigger dimensions themselves, or would it be on like the trigger values? Because at the moment they're just using the median. Is the focus more on dimensions, I imagine?
I don't know. It's just some of my my suggestion. I'm still working on that, but if you want, we can working on that together. So basically, what I think is the median. The median, their choice for the median is not very proof with math or something. They just have a very quick sentence in the paper, I believe. It's just that they're choosing the median because they think that is the most healthiness value, the most healthy value, because it stands within the boundary of that dimension. So they're just doing the median because it sounds natural for them. They don't prove it anyway.
So we can have one experiment with different other random values as well. And that's one different dimension and different values that can help to show that there's still available rooms for improvement. I think that would be the best. Or in hoppers or other environments as well.
Yeah. So maybe just some experiment to prove that the original choice is not the optimal one is enough. Yeah. Yep.
Yeah.
Okay. So worrying about the trigger implementation and not necessarily not touching yet the like activation. Just because in the paper it data to the model to activate the trigger. Not focusing on that at all, more just on the implanting of the trigger.
Yeah.
Perfect.
Yeah, I think you guys all understand what I mean by that. Because I can see you guys point something out perfectly in your presentation, and I can see you guys understand that the trigger or the reward, everything is a fixed value, like you guys did with the 75 percentiles or something.
Yes.
Yeah. So the by-for itself is a very simple idea, but they can still be a good paper because it works. But then if we can improve, or at least prove that it's not the optimal one, we can have room for improvement. It can also be a very great idea.
Yeah.
Yeah. So it's just some small things or some suggestion or something you guys can do in the next semester. But I think it's a great topic to do.
Were you still interested in us exploring the RoboDK environments as well, to see if we could implement Baffle or some other type of algorithm for that, or explore different attack vectors, as you say?
It depends on you. I think any direction is great for this one. I haven't looked into the RoboDK yet. I don't know what it's using for. Is it for robotic arms or just some manipulation test?
Yes, it's very similar, I think, to Manuscale 2 in that way.
Oh, I see. So yeah, because we have the submission, we have the subscription for the RoboDK, right? Yeah.
Right, we do.
Yeah. So maybe it can be a good alternative or a good findings if you can do it on RoboDK. I think we can provide you the subscription.
But before that, I'm also thinking currently what the current implementation of Baffle, we do not haven't implemented any detection or defense algorithm yet, right?
Yes, I believe so. We just need to run the Traj auditor just to collect a couple of values from that, and just to verify, because we have the current environment scores and we have like all of the data sets which we've verified, but we just need to run that as like just to triple check everything as part of the implementation.
I see.
Yeah.
Sorry, just on the detection front, that's something separate to Traj deleter. That's not the unlearning. That's, you'd also like to see how well our Baffle stands up to, like how hidden it is in the model / data set, correct?
Yeah.
Yeah.
Do you have any idea or any recommendations on like methods of detection? Just because that's not something that I had looked at.
I believe I remember in the paper of the Baffle, when you scroll down to the bottom. Yeah, when you scroll down to the bottom, it's have some very basic, like the spectral detection. I don't remember, but there are something they already implemented, but it's still fairly simple. They just added the detection later on when the reviewer asks for why don't you have any detection in your paper, and they just add a very simple experiment on the detection at the very bottom of the paper.
Yes. Yeah, I see that now.
Oh yeah, and they also implement the neural cleans. But it's weird that I cannot find it in the repository of them. I didn't find
the what? Sorry.
The neural cleans, I believe. Can you? So that is not the detection. That is for the sanitization of the trigger.
Right, yeah.
Yeah, they mentioned that they implement that, but there's nothing like that in the source code. They had it somewhere, I don't know. And it's also weird because the neural cleans is often used for the computer vision backdoor attack. It's never been used in the reinforcement learning attack yet, but I don't know why they still put it as a sanitization in the paper. So I didn't know how they really implement that.
Yeah.
So they claim that they do the experiment, but they had it somewhere. I don't know. That's weird.
Not present in them.
Yeah.
For our progress currently, would you prefer if we like how do I phrase it? Sorry. There's a lot of stuff that you just mentioned that would be like not outside of but outside of the scope that we were working on currently. Would you prefer that we have like a broader scope and not necessarily for example, I'm thinking like our CQL implementation currently completes 1.8 tasks, I believe. That's just off the top of my head. Would you prefer that we like bring performance like that up? Or would you prefer, you know, we have that working, it's working and it does a good job to a degree. That's fine. We can now use that and then continue on to something else. Would you prefer like a deeper drill deep on things, or a more shallow but wider spread?
I understand what you mean. Like you want a decent one that is working and then continue improve on some other field, rather than just dive into having a best ever model for that.
Yes, exactly.
So that is for the weak agent or for the clean agent?
I believe that both use basically this, like the same training logic. It's just slight tweaks. So our that's for our trained agent completes 1.8. I'm not 100% sure what the performance is or how we would evaluate the performance of the weak trained agent at the moment.
Yeah. Maybe I missed something, but can you explain what is the 1.8 again? Because I believe the Franklin Kitchen evaluation metric is a bit different compared to other Hopper or something.
Yeah. So, and I'm gonna speak, and if I'm incorrect, I'm sure someone will correct me. But my understanding is that we have environment, like an environment value, which is essentially the subtasks that we're completing. So an environment score of 1 indicates that we've completed one subtask successfully. For example, like pick a cube. So a score of 1.8 indicates that we have completed 1.8 tasks successfully on average across those, like across that training sphere. So our 2.8, I think, was our CQL training. I believe that means that we've completed 2.8 out of the 4 tasks that are possible to complete.
Oh, I see. So the matrix of the Franklin Kitchen is a bit different. It's not like the accumulated return for the whole trajectory compared to Hopper or Weka.
I haven't looked into Hopper that much, but I believe it's only slightly different to Maniscale 2. Maniscale 2 and Franklin Kitchen operate similarly from what I've seen.
Okay. So the metrics for the environments is more like how many tests have been completed rather than the total return of the whole episode.
I believe there is still a return value because I don't have that number down, but I believe when I was looking at the data sets to try and model out Maniscale 2 on our Franklin Kitchen, I believe there is a return value, but I think we've been using the environment variable just because it's an easier variable to comprehend. So we could look at return instead of environment variables if you prefer us to work based on that.
Yeah, because we would like our metric to something align with the paper. In the paper, they calculate the total return of the whole episode. Yeah, but because the environment like Hopper or Worker, it's just something continuously so it's not having some end, like some end conditions. But for the Franken Kitchen, we know what is the terminal state is that we correctly put the cube or something. So yeah.
Because for like the Carla Lane task, there's not a distinct end. It's just the reward or the return. Sorry, it's like how well it has kept within the boundaries and stuff from memory.
Yeah.
So it makes it a little different.
So it can be like both of that. Like it should both. So we should. So we can still keep the if it have completed the test or not. We can still keep that. But we can also log out and calculate the total return as well alongside of it.
Yep.
Yeah, because as the weak agent, it can have a scenario that it already complete the test, but somehow it moved the arm in not the correct way, so that the total return becomes a very small value.
So it like kind of locks its way into doing the task.
Yeah, until it can complete the test normally, but the total return is much different compared to the clean agent. So that should also be a metric. Yeah. Yeah. So I think you can still try to improve that to at the point that it works in a decent way.
Perfect. So you would probably prefer, I'm describing it as depth, but like completion, I suppose. You work slightly more on the completion of the things that we have at a good enough level at the moment. Get them improved a little bit, and then focus on expanding a little bit more once we have those slightly more up to snuff.
Yeah, because it can help you quicker in the progress. So that you can try more ideas and more ideas you have.
Perfect.
Do you prefer to? Okay, so the first scope at the first stage, our scope is something like we're trying to have something work perfectly on many skills, Franken Kitchen. But now when we discussed, I can see there are also a lot of improvement or some direction we can follow. Like we improve the method for the simpler environments, like the hopper or the worker. So do you want our next semester to still continue with doing it perfectly on many skills and then move it to the physical? Or you want it to be more a research project, try to improve the method for the environment like Hopper?
I think it's moved a little bit into the research project with the testbed simulation would be good. But one of critical thing is always existing detection and defense that we haven't considered implemented yet. So in complement to Minh An's suggestion, I believe to some stage, maybe not right now, but maybe in this next semester, we are also looking at some detection defense and then move on to new attacks implementation that to support us as well.
Yeah, okay. So I can see that, we can still keep our project like this one. We can still trying to evaluate different attack, implement all that on many skills and Franken Kitchen. But we can also add some smaller thing is that like the detection method. Because alongside with the attack, we also need to have some detection and we want to evaluate that as well.
Perfect. Do you mind if we find like papers or like methods that we think would be appropriate? Do you mind if we just send them to you to get a quick like sanity check, double check?
Yeah, that would be great.
Yeah, I think most in terms of sanitizer and detections, they would be more lightweight because the purposes of learning when we transfer from online converted to offline, the purposes is have to be quick and efficient. So detection would be the best thing. sanitization as well. So if you find out any existing works, you can also share to us. So we can quickly have a look and see if this is great, worthy for us to implement.
Yeah. I can see when I search for some detection method, I can see most of them is just for the deep learning field, not much for the reinforcement learning. So it will be also a very good contribution if we can have some more for the offline reinforcement learning detection. Yeah.
Just on, you mentioned unlearning and then you mentioned sanitization. It could just be a gap in my knowledge what the difference between those ones are.
The sanitization is when you know there is a trigger, there is a backdoor attack in your model, and you want to. So the unlearning is more like some broader use. You just want to remove just want to remove some point of data from your training set. But for sanitization, it's more specific, just for remove the trigger attack.
Removal.
Yeah.
Okay.
But but I think it's easier to work on some detection method first rather than the sanitization. So there's a lot of detection, like just some very simple and statistical method, like when you look at the range or some distribution of the reward and distribution of the states, you can know is there anything weird happen with your dataset. Yeah. So the detection, I think it's more simpler and more likely to implement, and it can be easily adapt from deep learning to reinforcement learning as well.
Easy. I think we were also discussing, what's today? Wednesday. Yeah, we were discussing yesterday, last night, potentially as the scope has kind of shifted, as things have moved along, we were potentially going to go back and have another look at the SRS and just look at what our original SRS looks like, look at what it potentially has changed to. So would it be alright if we shot you, once we go back and have a look, shot you through the new SRS and just see how you think it aligns with our new goals now that things have kind of shifted around a little bit?
Yeah.
Yeah, we'll send you some emails with a couple of questions just regarding the current scope of it. Like, I know we discussed going through a dashboard implementation for that, but I'm not too sure if we still want to pursue that as part of the scope for this semester. But yeah, we'll just come up with a list of questions.
I think the expo will be in November or December, right?
Yes.
Yeah, so the dashboard should be in the next semester rather than this one.
Right.
Yeah. I think this semester working more than a baseline for everything you're gonna do in the next semester. You understand this semester more like for you to understand everything for your project, the unlearning, the attack, everything you want it to have a correct implementation first. And then for the next semester is for the improvement, more evaluation, more numbers, metrics you collect, and then have something working and put it on a dashboard so we can showcase on the expo.
Yeah, so we're going to be exploring, as you said, looking at some new papers. We can present those to you. We can also look at, as you said, the hopper and looking at sanitization implementation as well. I think during these holidays I'm going to explore more of that Robo DC environment, see how we can potentially improve that and implement it. And if it's still within scope, we'd like to look at the implementation on the robot as well, as I think that would be a great centerpiece for our presentation as well at the end of the year.
I see, yeah. The math skill is not actually something yet you must complete. It's just some of my suggestion when I'm looking for different environments. If you can working on the robotica and you feel that suits more with your plan right now, you can easily shift it to use that. It's not a problem at all.
Okay, no worries. And just
Yeah.
with the
Yeah.
ManiScale 2 environment, currently we do have that pick cube task complete. How many of the tasks did you want us to complete for that? Because I know there's a lot of them compared to compared to Frankie Kitchen, which only has 6 total tasks, I believe, and currently we have most of them. What was the scope regarding that?
I don't really know about what are the other tasks, but
Okay.
I can think you can choose it based on what you want to show in the expo.
Okay, no worries.
Yeah, so for the PQ is a good example here because in the expo you can easily show it that your robot arm can pick something up, or you can choose some other tasks like moving around or open a microwave, bring a microwave to the table. I don't know, but
Yeah.
yeah. So it depends on what you want to showcase on what you want to do in the next in the final presentation of the product.
Yeah, I think that just depends on which, because I know the robotic arm, I can't remember the exact details from memory which one it was, but the ManiScale 2 uses the Panda arm, whereas Frankie Kitchen uses a different one, which has less sensors. Like it has 7 degrees of movement, whereas the ManiScale has, I think, 9 from memory. So that might be something we need to look at when testing with a physical robot, just about implementation.
Can we still access to the lab in this break after the semester break?
We can still access the lab. Yeah.
Yeah. So I think in the break you guys can have a look on the physical device first, and then you can know what should be the things you want to do in the next semester when you really look into the physical device.
Alright, so yeah, just during this break, I don't know if you need specific access on like an ID card for that, but yeah, if that could get approved, just so that we can come in and have a look at the robot, or if we need to like book in specific times for that, that would be great, thank you.
With that one,
Yeah.
I think have a physical is also a good choice. In this semester break, so Ming-An, are you available at any time to go to the lab? And then I can also ask Donovan to come as well with you, so that you can see whole team.
I can be there anytime outside the work hours, 9 to 5.
95 noon time, 12 to 1.
12 to 1 is okay for me.
Yeah. I think it's okay to have a introduction about the robots first, and then but the work is still doing on some other detections and implementation. I think your team can send me, or maybe Timothy or Josh, you can centralize on these the front number of your student cards.
Yep.
And the expiration dates of your cards, and share it to me as well, so that I can do some others grant permission access, and we can also catch up with Ming-An in person, and with some other researchers who are doing on robotic as well, so that you know what the robotic looks like and what it does. Ming-An, is it part the evaluations on the robots? It can be considered in your current projects, Ming-An?
No, I don't think the physical one related too much for my project. Yeah, my one is for more like a theoretical research problem rather than engineering or physical.
Yeah, so I think we can more leave it. We can introduce you for sure.
Yep.
For implementing on the hardware for demonstration I think because the team is they still are doing we are conducting. We have another capstone team trying to conducting the middleware, conducting the middleware for robotics. I think that we can migrate to it when the team when that middleware is at the stable stage. I think it's not urgent. It's not urgent right now. But if you want to have a look on the robotic, then we can introduce you in the break.
Yeah, no more.
I think we can still prioritize the simulation
Yes.
testing and evaluation rather than the physical one right now.
Okay. Yeah.
Because second thing, we still have a lot of area to improve rather than applying to the robotic arm.
I see. Yeah, because if you apply robotic arm, there will be some a little bit beyond and away from our current project scope. Will get your team a little bit complicated. So we still want, but maybe we defer it until maybe when we deploy to the dashboard as well. In that part, it can be in the last sprint, I think.
Yeah. Okay.
Last spring of the next semester. That will it will make your team less stressful. Otherwise, if we introduce right now with the robotic arm, I think there will be a lot of stressful because we have a lot of other people when they're crazy about the things. They have to do a lot of measurement. On the robotic, when they do with the physical, you have to measure where you want to put it into on a table or which are the corner. You have a clear measurements on it. So, but if you're doing this, then it will be more in terms of task construction rather than the deployment of the learning. Mm-hmm. So we still can consider it, but maybe at the last break to ease your burden and stress, I believe.
Yeah, we just don't want to leave it to the very last minute and then have a lot to do during that last sprint. We're totally happy to do the dashboard during that last sprint, get that all hooked up. We just don't want to... I've got experience using robotics before, just not to this specific degree. But yeah, if we can just have a look at it just during the break, we don't have to do any implementation during that time. I just want to understand what the sensors are and what the exact procedures are going forward with that.
Yeah. Just have a look on it, then it will be great. Yeah, I think you can centralize the student IDs. And then let me know. And then let me know by email. And then in the email, you can also show that, okay, you plan to come have a look or to see what is going on. So in that case, then I can introduce you to other people who are doing on the robots as well. So that this is good for collaboration or good for networking with other people as well.
Yeah, okay.
Alright,
I think that wraps up.
Maybe we can also catch up with the whole team in person at that time.
Yeah. I'm good with that.
Alright.
Sounds exciting.
Okay. Thank you, everyone.
Thank you so much.
Thanks so much. Thank you.
Okay, thank you. Thank you, Minh. See you, bye.
Yeah, thank you, everyone.
Thank you. Okay, how was that, guys?